Hey guys, my name is Z and you're watching Makes It Easy. And welcome to IGCSE Chemistry for the second topic, which is acids, alkalis and salts. And for the lessons that I'll be covering are Introduction to Acids and Bases, Acids and Alkalis, Reactions of Acids, Alkalis and Bases, making a soluble salt, which is copper sulphate, making insoluble salt, which is lead sulphate, titrations, and making ammonium sulphate. So here are some basic facts. We have diatomic elements and monatomic elements, and some ions that we always see, and some acids and ammonia. So moving on, we have our first lesson, which is Introduction to Acids and Bases and Indicators. So here are some definitions. Acid is a H plus donator or H plus ion donator, and alkaline is a H plus receiver or OH minus donator. And oxide is O2 minus, it's a base and it's insoluble in water. And for hydroxide, it's OH minus, which is alkaline and it's soluble in water. And these three acids, hydrochloric, nitric, and sulphuric acids, are one of the most common acids that appear in IGCSE chemistry. And here are some base and alkaline, which includes calcium carbonate, calcium oxide, zinc oxide, and sodium hydroxide. So here are some indicators. Litmus paper is less useful than universal indicator because the litmus paper doesn't show the specific pH and it only shows if it's alkaline or acidic. But universal indicator tells us the acidity or the alkalinity of the solution. And phenolphthalein is colorless in acidic solution, and phenolphthalein is pink in alkaline solution, which will be useful for titrations, which we'll look into later. And methyl orange turns red in acidic solution, and methyl orange turns yellow orange in alkaline solution. So here are some colors. We have the acid of HNO3 and alkaline, which is NaOH. And for litmus paper, it turns red for acid and blue for alkaline. And methyl orange, it turns red for acid and yellow orange to alkaline, as we talked about just now over here. And phenolphthalein is colorless in acid and it's pinkish in alkaline. And for universal indicator, it's reddish orange in acid and very purple for alkaline, which shows that sodium hydroxide is very alkaline. Then we have acids and alkalis. We have this neutralization reaction, which is acid plus alkali equals salt plus water. For example, sodium hydroxide, an alkaline, plus hydrochloric acid equals sodium chloride plus water. And here are more reactions that you can have a look for yourself, which are all neutralization reactions. And here's neutralization in terms of ions, which is H plus OH minus is H2O. And as I talked about, acids are proton donor and alkaline is proton acceptor. And basically the neutralization for acids plus alkali is the same as acid plus bases, because base acts as the same as alkaline, but it's just insoluble and soluble. That's the difference. And here are some other equations like metal plus acid equals metal salt plus hydrogen, and the short form for it is MASH, M-A-S-H. And here we have sodium hydroxide plus nitric acid equals sodium nitrate plus water, which is a neutralization reaction. And sulphuric acid plus zinc equals zinc sulphate plus hydrogen, which is the MASH, metal plus acid. So we have reactions of acids, alkalis, and bases. And here we have a concept called spectator ion. And spectator ions are ions that are not used in a reaction. And let's say we have this reaction like MASH here. And for, let's say if it's acid is always aqueous. And to write the equation, the aqueous split into the ions, and solids and gas don't split into its ions. And spectator ions get cancelled out. To demonstrate what I mean, I have hydrochloric acid plus zinc equals zinc chloride plus hydrogen. So notice how only hydrochloric acid and zinc chloride are aqueous. So only these two elements, so these two compounds get split into its ions. So we have 2H plus 2Cl1 minus plus zinc, which is solid, equals zinc, which is 2, and Cl1 minus, aqueous. So we just cancel out both sides which have the same ions. In this case, the spectator ion is chloride ion. As you see, the 2Cl1 minus and Cl1 minus is the same. So you cancel them out. So it leaves you with 2H plus zinc, zinc equals zinc 2 plus H2 as a gas. And one thing to note is that Cl2 is a molecule. And then we have reactions of acids, alkaline and bases, or like to more of the spectator ion concept. So here we have split into like aqueous split into its ions, and ions then cancel out the SO4 2 minus. And then here we have more. And you can have a look for yourself or comment down below if you still don't understand, and I'll gladly help you. Then we have reactions of acids, alkalis and bases. So for the solids we have zinc, magnesium oxide and magnesium carbonate, and you can see each reaction like zinc plus MASH, metal plus acid, metal oxide plus acid, and metal carbonate plus acid. And for the first one, MASH, we have zinc is fizzing and gas is produced, which is called effervescence. And to test if the gas is hydrogen that's produced, carry out the squeaky pop test. And for magnesium oxide plus sulphuric acid, there's no observation as the solution is white and cloudy. That means that it's a precipitation reaction because magnesium sulphate is produced. This is because water is also produced. The solution, however, is getting hotter and warmer as it is an exothermic reaction. And for the last one, the reaction fizzes vigorously and gas is produced. To test if the gas is carbon dioxide, we should collect the gas in another test tube with lime water. If carbon dioxide is present, lime water will go cloudy. So we have more reactions of acids, alkalis and bases. We have MASH, metal oxide, metal carbonate as we talked about just now, and the neutralisation reaction. So then we have making a soluble salt, which is copper sulphate. So here's preparing copper sulphate crystals. You can have a look for the equipment yourself and the method. Just have a read through, and we'll move on in a few seconds. And we'll move on now. And here's the process of making copper sulphate. Like first we prepared a spatula like these things, then we heated and mixes the copper oxide and sulphuric acid. Then you can see the process like filtering, drying and reheating to evaporate some of the water, and then leave it to crystallize via the process called crystallization. Then we have making a soluble salt as well, copper sulphate, and here's more details like copper oxide plus sulphuric acid equals copper sulphate plus water. And copper oxide is a base, so it's S, and it's not soluble in water. And copper sulphate is a soluble salt, which is aqueous, so it dissolves in water, so that's why we have to evaporate some of the water and leave it to crystallize for the water to further evaporate. And here's filtration technique and some description. So moving on, we have making insoluble salt, which is lead sulphate. And here's making the two soluble salts together. You have a reactant and reactant, the soluble salt and soluble salt. And the product will be a soluble salt, and this will be insoluble salt. And when you have an aqueous solution, like here soluble salt plus an aqueous solution, when you have AQ plus AQ, it will be the product, one of them will be a solid, because an aqueous plus an aqueous will always be a precipitation reaction. Not always, but it will mostly be a precipitation reaction which produces solid. So for step 2, we have filtered the mixture and then wash the insoluble salt. And lastly, dry the insoluble salt in a, let's say, warm oven, or use like paper towel to dry it. And then we have more details over here, lead iodide and potassium nitrate. When you add two aqueous solutions together, a precipitate will form, which is a precipitation reaction, which is a reaction that produces a solid. And here I prepared an insoluble salt by reacting together 20 cm cube of lead nitrate solution and 20 cm cube of potassium iodide. And here's the equation. And the name of the precipitate, which is an insoluble salt, is called lead iodide, right here. And what color is the precipitate? It's meant to be yellow. So insoluble salt equals precipitation reaction. And moving on, we have titrations. Titration is a scientific procedure that measures volume precisely to determine how concentrated an acid or alkali is by using the opposite solution. So here we have some description for endpoint. And universal indicator will be inappropriate to choose as an indicator because you can't exactly measure when the solution has turned neutral. So as I talked about for the first few slides, Phenolphthalein turns colorless in an acidic solution, which makes it very useful for to see any color change and any pH change. So we have titrations equipment. We have a burette, a pipette filler, and a pipette over here. And be careful while handling it because it's quite costly. And then we have the titration experiment. So here we have an experiment over here and the result. And we have a rough over here, a rough result. And concordant results mean that that's a 0.2 milliliters or 0.2 cm cube difference. So for the first, second, and third experiment, you can see that the first and the second have within 0.2 milliliters difference. Like there's only 0.1. So these two are concordant results. And you can see 27.3 is not within 0.2 with 27.55. But you can either use these two results or this and this because these two are in range. And then we have lastly we have making ammonium sulphate. So here are the steps to make ammonium sulphate that you can have a read for yourself. And we'll move on in a few seconds. And we'll move on now. And here's the setup for making ammonium sulphate. It's like a titration, a burette, and a clamp, and then titrant, and here analyte, and a conical flask. And lastly, to see if a salt is solid or aqueous, we have this thing called the Solubility Rules. And you can find more detailed versions online, but here's a more simplified version. So here we have salts containing these things and these things. Like we have nitrate, sulfate, potassium, sodium, chloride, carbonate, iodide, and oxide. And if it is soluble or insoluble in the salt, for nitrate, everything is soluble. And for sulfate, everything is soluble except for barium sulfate and calcium sulfate, it's insoluble. Potassium, everything is soluble. Sodium, everything is soluble. And for chlorides, everything is soluble except for silver. Silver chloride is insoluble. And carbonate, everything is insoluble except for potassium, sodium, and ammonium. And for iodide, everything is insoluble except for potassium, sodium, and ammonium. And for oxide, which is a base, as we talked about just now, everything is insoluble. So that's it for this second topic of IGCSE chemistry, which is acids, alkalis, and bases. I hope you guys have enjoyed this, and leave a like and subscribe if you've enjoyed it. And follow my Instagram down below in the description box. And I hope you guys have enjoyed it, and I'll see you guys in the next video. Until then, stay safe and peace.